Hello students, let us explore this collision lab. So the first we're going to do is to explore the one-dimension option. So here you have two bodies, right, uh, that are going to be part of a collision. Which are the options you have, which are the controls that you have in this case? You can show here the velocity of the body. You will be able to show also, the linear momentums. The velocity vector will be represented by a green arrow. The linear momentum will be represented by a blue arrow. You can include the center of mass. You could include there also the kinetic energy. You can just show the values of velocity and linear momentums. You can pick between elastic collision or inelastic collision. In this case, I will just show only as part of the screen the values of velocity and linear momentum. We know that the vector linear momentum would be pointing in the same direction that the vector velocity. So I will just turn off the vector linear momentum. I will let only the vector velocity here, and I will keep values and then velocity. I will select an elastic collision. You have a knob to control here the mass of the bodies, so you can increase the mass. I can, if I want, put two bodies with the same mass here by moving this knob. I can make this move slowly, and then I can just click here in plate to see how the collision occur. So let's see this case. At the beginning here we have one body that we have a velocity of 1 meter per second. The other body number 2, we have a velocity of 0.50 meters per second. If you want to change the velocity, only thing you have to do is to grab the tip of the arrow and with the mouse, and you can just move left or right, and like that you can increase or decrease the magnitude of the velocity. Of course, as you increase or decrease the magnitude of the velocity, the linear momentum will be also changing here. Well, if you want to find the initial linear momentum, only thing that you have to do is just to add the linear momentum of this body 1 with the linear momentum of the second body, right? Remember that they are vectors, so this direction matters, right? So you are taking this on positive, this over should be negative, right? So let of them move with the collision. And now after the collision, you can just collect the new data, that is the velocity of each body after the collision, and of course the direction of the velocity, which is going to be the same as the direction of the linear momentum, or the vector linear momentum, and you have here the magnitude of the linear momentum. Each you add kinetic energy, each show you the kinetic energy of the system. But well, we can calculate the kinetic energy, we know, with the velocity we have here, okay, and the mass of the bodies. As you know the mass and you know the velocity, you can find easily the kinetic energy of each body. So it's very easy to collect the data here. Let us try one more case. So we're going to reset. I will increase the mass of one of the bodies a lot. I will decrease the other one to 1 kilogram. I will increase the velocity. So these are the values of velocity and linear momentum for the body 1 before the collision, values of velocity and linear momentum for the body 2 before the collision. We have the collision now, and then we have new values of velocity and linear momentum for the two bodies. And look at, how now, due to the change in mass that we did, the direction of motion of the body one have changed with respect to the previous example, right? Well, you can now reset these and move to an inelastic collision, so to a completely inelastic collision. Let us just use pretty similar masses, and let us use not very different velocities, and let us have the collision. Now it's going to be a completely inelastic collision. So you can see how after the collision the bodies are going to stick together, right? So now they have the same velocity, and of course they will have also the same linear momentum. Well, they will have a linear momentum depending on the velocity and the masses. The linear momentum is going to be a little bit different for each of them because they have different masses, right? So that's clear. So this is, one dimension. You can also explore two dimensions. So now when you are working in two dimensions, right, you can modify the directions of the vector velocities, right? And of course you can modify the masses also. You can select, right, if you want an elastic or inelastic collision, right? And you can also have your values, right? So let us represent the collision now. And this is the collision, the values of velocity before and after, the values of linear momentum before and after, right? So we can increase the number of bodies that are part of the system with these arrows, or we can decrease that number. So these are the different options. I encourage you to keep exploring, and I'm pretty sure you're going to discover a lot of other options that are part of this simulation. Thank you for your attention. Remember to subscribe to my channel. Remember to support our work.